Hi, everyone, and welcome to our example 4, a little bit more in depth because you have to come up with the formula for each sequence. So it can be tough for some and other people's brains just take right to it. So please don't get frustrated. With practice, these usually get easier, but I'll be the first to admit that my brain doesn't sequence the same way as some others. So it takes me a lot to figure these out as well. So just give them practice over the next coming practice and lessons, and it should keep getting better. So what we're trying to do is write the equation a sub n. And so for this first one, part A, if you think you know what you're doing, pause the video and try them on your own. But I encourage you to kind of pause throughout if you think after I get through a few examples, if you can try the rest. So the numerator here for this top one, part A, is all ones. So that's constant. That one won't change. But the denominator goes 2, 4, 8, 16. So it looks like it's taking the previous number and timesing it. So 8 times 2 is 16. 16 times 2 would be 32. So it seems like the formula might involve something times 2. And that's very intuitive and true, but it's how does it involve something with times 2? Well, what it does is it takes the number 2. This is actually really 2 squared, 2 to the third, and 2 to the fourth. So it's taking the previous number, which is 2, and then raising it to a new power. So that example will look like this. A sub n equals 1 over n squared. So again, some people get that right away. Others really tough. Question B is going to be a one where you look at, well, how do the numbers change in between? So this one changes by 2, 7 and 9 changes by 2, and they all change by a value of 2. Well, since that's the case, that is considered what's called linear because it only takes a changing constant value immediately in the first tier. So that's common difference, or the first difference is all going to be 2's. So that means it has to be linear in shape. So that's going to be your slope is these 2's. And then you ask yourself, well, what would be one term back? Because if this is n equals 1, what would be one term back in order to figure out the 0 term, which we can't plug in 0 because we can only plug in positive integers, but the 0 term would be the y-intercept. So that would look like if we go down by 2, we get a value of 3. So this one's equation is a sub n equals 2n plus 3. Again, I encourage you to pause the video and try C and D on your own. Letter C is looking at alternating negative, positive, but they all stay the number 1. So in that case, we had this happen in example 2. There is a pattern that becomes like a formula almost as how do you make it alternate. It's going to be negative 1 to the n. So a sub n equals negative 1 to the n. Again, the more you see that, the easier that will be to pull out. The last one's a little trickier for sure. We have 3, 6, 11, 18, 27. So those ones, what do they go up by? The first two, 3 to 6, and so forth, goes up by 3, 5, 7, 9. So it looks like it goes up by odds, but it's not a constant number. So anytime you don't get a constant number, you want to go down one more tree, kind of branches in that. And it looks like 3, 5, 7, 9 all are going up by 2's, which means this is a quadratic or second tier difference, second degree difference. So that's going to be a quadratic. So you got to come up with a quadratic function. Well, the way to do that is that it goes up by 2, so n squared. And then where would you be if you went back one number? Meaning this would have changed by only, by 1, right? So if you went down by 1, you would get a number of 2. So that looks like that's my first term is going to be 2, and n squared is going to be my quadratic piece. So a sub n equals n squared plus 2. This one does take some time, but I know you can eventually get it. Please use the other videos, author and action videos, everything to help you through this lesson as we continue next onto recursive.